Have you ever wondered what's pulling our galaxy towards a mysterious point in space, known as the Great Attractor? Join us on a mind-bending journey as we explore the fascinating science behind this enigmatic cosmic phenomenon. Strap in and hit play now to satisfy your curiosity and discover the secrets of the Great Attractor. Don't miss out on this epic adventure. Our galaxy, and 100,000 of our neighboring galaxies, are hurtling towards a massive point in the universe known as the Great Attractor. This region of space is about 220 million light-years away and is what scientists call a gravitational anomaly. Just how massive and powerful is this region? Take into consideration that of the 300 billion stars in the Milky Way, most of them are a lot smaller than our Sun. The Great Attractor is believed to have the mass of a quadrillion suns. What is the Great Attractor? The Great Attractor is a purported gravitational attraction in intergalactic space and the apparent central gravitational point of the Laniakea supercluster. The observed attraction suggests a localized concentration of mass millions of times more massive than the Milky Way. However, it is inconveniently obscured by our own Milky Way's galactic plane, lying behind the zone of avoidance, ZOA, so that in visible light wavelengths, the Great Attractor is difficult to observe directly. The attraction is observable by its effect on the motion of galaxies and their associated clusters over a region of hundreds of millions of light-years across the universe. These galaxies are observable above and below the ZOA. All are redshifted by the Hubble flow, indicating that they are receding relative to us and to each other. But the variations in their redshifts are large enough and regular enough to reveal that they are slightly drawn towards the attraction. The variations in their redshifts are known as peculiar velocities and cover a range from about plus 700 km/ to minus 700 km/, depending on the angular deviation from the direction to the Great Attractor. The Great Attractor is thought to be the gravitational center of just this supercluster, comprised of our galaxy and 100,000 others. The Great Attractor is not, then, a celestial body in and of itself, but instead a location where everything else collects like the bottom of a bowl. First discovered. It was first discovered in the 1970s that the Milky Way moves through space. Through a series of peculiar velocity tests, astrophysicists found that the Milky Way was moving in the direction of the constellation of Centaurus at about 600 km/. Then, the discovery of cosmic microwave background, CMB, dipoles was used to reflect the motion of the local group of galaxies towards the Great Attractor. The 1980s brought many discoveries about the Great Attractor, such as the fact that the Milky Way is not the only galaxy impacted, and an approximation of 400 elliptical galaxies are moving toward the Great Attractor beyond the ZOA. Where is it? The first indications of a deviation from the uniform expansion of the universe were reported in 1973 and again in 1978. The location of the Great Attractor was finally determined in 1986. It is situated at a distance of somewhere between 150 and 250 million light-years, 47 to 79 mpc, the larger being the most recent estimate, away from the Milky Way, in the direction of the constellations Triangulum Austral, the Southern Triangle, and Norma, the Carpenter's Square. While objects in that direction lie in the zone of avoidance, the part of the night sky obscured by the Milky Way galaxy, and are thus difficult to study with visible wavelengths. X-ray observations have revealed that region of space is dominated by the Norma cluster, ACO 3627, a massive cluster of galaxies containing a preponderance of large old galaxies, many of which are colliding with their neighbors and radiating large amounts of radio waves. Why is it so mysterious? Part of the reason the Great Attractor is so mysterious is that it happens to lie in a direction of the sky known as the zone of avoidance. This is in the general direction of the center of our galaxy, where there is so much gas and dust that we can't see very far in the visible spectrum. We can see how our galaxy and other nearby galaxies are moving toward the Great Attractor, so something must be causing things to go in that direction. That means either there must be something massive over there, or it's due to something even more strange and fantastic. When evidence of the Great Attractor was first discovered in the 1970s, we had no way to see through the zone of avoidance. But while that region blocks much of the visible light from beyond, the gas and dust don't block as much infrared and X-ray light. As X-ray astronomy became more powerful, we could start to see objects within that region. What we found was a large supercluster of galaxies in the area of the Great Attractor, known as the Norma Cluster. It has a mass of about 1,000 trillion suns. That's thousands of galaxies. While the Norma Cluster is massive, and local galaxies are moving toward it, it doesn't explain the full motion of local galaxies. The mass of the Great Attractor isn't large enough to account for the pull. When we look at an even larger region of galaxies, we find that the local galaxies and the Great Attractor are moving towards something even larger. It's known as the Shapley supercluster. It contains more than 8,000 galaxies and has a mass of more than 10 million billion suns. The Shapley supercluster is, in fact, the most massive galaxy cluster within 1 billion light-years, and we and every galaxy in our corner of the universe are moving toward it. Will it destroy us? What astronomers know for sure is that our galaxy and all of those in our supercluster are headed toward the Great Attractor. No one knows what this might mean, or if our planet is in any eventual danger. Astronomers say it'll take a few years before we know more about this anomaly. Some astronomers don't consider it a threat, while others posit that all galaxies and clusters are clumping into greater and greater superclusters, and that this may be how the universe ends, as part of what's called the Big Crunch, which could theoretically be followed by another Big Bang. In conclusion, the mystery of the Great Attractor continues to captivate scientists and space enthusiasts alike. With its incredible gravitational pull and unknown origin, it beckons us to explore and discover what lies beyond. As we continue to study and uncover the secrets of this enigmatic structure, we invite you to join us on this exciting journey of discovery. So keep looking up and exploring the wonders of the universe. Who knows? Maybe one day we'll finally uncover the truth behind the Great Attractor. Don't forget to subscribe to our channel to stay updated on the latest developments in the world.